Hi again. Well, we're still going with the normal distribution here. And on the second page of the notes for normal, I put a screenshot of Staplet. So you can, and also some directions up here. So you can refer to this as well as the video. So let's just refresh our memory on that one. In the Staplet normal calculator, make sure the operation menu is set to calculate an area under the normal curve. So if you're finding a probability, you're finding an area, okay? So this is for finding a probability. We will go the other way as well, but that'll come in a little bit. Okay, then you're going to type in the values for the mean and the standard deviation and click on plot distribution. Then you're going to select the type of probability you want, either between, two values, to the left, to the right. That's pretty much all we're using right now. And then click on Calculate Area. And notice that Staplet will give you the z-score of the value if you, it'll give you the z-score and the probability, and it'll also show it to you on the plot, okay? Great, okay, so let's do another example. Example 2, in a medical study, the population of children in Wisconsin were found to have serum cholesterol levels that were normally distributed, so they have to tell us, in any of these examples, they have to tell us that we're using a normal model, right? With the mean, and also I'll mention something about the symbols too. When we're using a theoretical model, we use the population parameter. So that's why we're using the Greek letters, mu and sigma. And so even though this is probably from some kind of study, right? But we're kind of just now saying that this is, theoretically, this is the population. Okay, so the mean is 1.75 milligrams per milliliter, I believe that is, and a standard deviation of 0.30 milligrams per milliliter. Okay, so define and draw or paste, and then label the normal model for children's cholesterol in Wisconsin. Okay, now if you were typing your notes, you could copy and paste this from Staplet. I'm going to draw it. And just draw. It doesn't have to be perfect, so just kind of estimate your normal curve there. So the define, let me use a different color for define. So the define is x is distributed as normal, parenthesis, we write in our mean and our standard deviation. So 1.75, comma, 0.3, or 0.30. The draw part I'm doing in purple, and that's I drew the normal curve, the bell-shaped curve, and then in the center I'm putting the mean, which is 1.75, and I'll put the units underneath. And we always try to divide the right side and the left side into thirds, right? So I'm going to put 1, 2, 3, with the third one landing about where it comes down, where the normal curve comes down to the axis. 1, 2, 3. So that's thirds. 1, 2, 3. Okay, that's just approximate. And now I need to go ahead and add my 0.3s and subtract my 0.3s. Or, as you saw in the last video, I could just go to Staplet and let it calculate that for me. Since I'm going to be going there anyway, I'm going to do it. So I'm going to change my mean. I've already got Staplet from our rainfall example. So I'm going to put in our new mean of 1.75 and our new standard deviation of 0.3 and hit plot distribution. And then it resets the whole bottom of the graph because it's on a whole different scale. Okay, now I've got these numbers right here, and I'm going to write them on the notes and then I'll show you. So 1.75, 2.05, 2.35, 2.65, yep, that looks like it's going by 0.3s. And then going down from the middle, 1.75 was the middle, 1.45, 1.15, 0.85. Okay, let me go back to the notes to show you that I just wrote that. And then we need to write our variable in units on the bottom, or you can, if you want to make a title, and if you want to split it into two, you're welcome to, but just have it somewhere. This would be children's cholesterol. So I think in this one it's kind of long, so I will split it up. I'm going to say children's cholesterol in Wisconsin. And then the variable, because what we're labeling is the scale. So what do these numbers on the scale mean? Okay, so these are serum cholesterol levels in milligrams per milliliter. Okay, so that's define, draw, and label, okay? So that's our model that we're using. Remember, this is a theoretical model. Okay, next question, part B. A child has a cholesterol level of 2.11 milligrams per milliliter. What is the percentage of children in Wisconsin who have cholesterol levels that are higher than this child's? Okay, so I'm going to write a probability statement for that. Percentage, think percentage, probability, area, those are all referring to the same thing. Because this area under this normal model is equal to 1. That's the whole thing, the whole area. Okay, so probability that x is higher than 2.11, so greater than 2.11. And we talked about how I could write greater than or equal to. Mathematically, that's the same. I tend to match the wording. So this one says higher, which to me implies it's above that, not including that. But I wouldn't mark it wrong. It's the same number. Okay, so now we're going to go back to Staplet. It says calculate the area, and we want to select to the right of a value. And then we want to select 2.11. Whoops, I got a typo. 2.11. Calculate area. And if you do this show labels, it just remembers it. So I kind of like that. So I could shade from 2.11 to the right, and I'm going to get an area of 0.1151. So let me do that on the notes. 2.11 is somewhere in here. I don't want to take the time to figure out exactly where. This is 5 and that's 35. I'm just going to estimate. It's 0.1151. Okay, and then I also could answer the question. Or I could say, well, I don't want to start with a number. The percentage of children who have a higher cholesterol level than 2.11 is 11.51%. Okay, so since it asks for a percentage, I could also just write or in my probability statement, or 11.51%. And in my open math, be really careful as to whether it's asking for a decimal or a percentage, okay? Because it might, depending on the coding, it might mark it wrong if it's not in the right form. So if you see a percent symbol after the box, it's looking for a percentage. If you don't, it's looking for a decimal. And it probably will say in words too which one it's looking for. Okay, let's do another one. Find the percentage of children in Wisconsin who have cholesterol levels between 1.3 milligrams per milliliter and 2.23 milligrams per milliliter. And that reminds me, I didn't put my units in my sentence there. Okay, so this is between, so we get to practice that between notation again. Probability, with between, we're going to start with the number. So open parenthesis, I'm going to put the smaller number, 1.30, less than or equal to x, less than or equal to 2.23. Okay, now I'm going to go to the app. Got my same model, so I don't need to define it again. Now I'm going to select between, and we've got 1.3 to 2.23. calculate area. Okay, so that is 0.8784. Okay, and I'm also going to write down the, whoops, just threw my pen. I'm also going to write down the z-score because we're going to come to z-scores in the next video. So 1.6. Oh, that's for, oh, I see. That's for the left boundary. So that's for that one. And z-score, I'll show you what I'm writing in just one second here. Just had to write it down while I can see it. Okay, so the probability of being between 1.3 to 2.23 is 8.8784. Okay, and it's written in terms of percentage, so I could also change that to a percentage, 87.84%. And then on the output for Staplet, it also shows me the z-score for each value. So we've looked at z-scores a little bit already. We're going to return to that in the next video. So I just wanted to show you that as well. So let me see if I can shade this on here. It's going to overlap the pink a little bit, but I'm going to do this one in green. So from 1.3, so I'm going to estimate that 1530, it's about there, and 2.23 is going to overlap the pink here a little bit. I'm going to shade that in. And that's an area of 8.8784. So that's quite a bit, right? And then what the z-score is telling me is how many standard deviations away from the mean that is. So the z-score for 1.3 is going 1.5 standard deviations below because it's negative 1.5. And the z-score for 2.23 is 1 and a little more, 1.16. Okay, so we'll pick up there and I'll remind you what a z-score is in the next video. So I'll see you there.